Okay, hi everybody. I'm Kaveh Vahedipour. I'm a senior software architect at ArangoDB. And this is the third part of the cluster administration guide. I'm just gonna check real quick if there is, let me see if I'm looking at the chat window real quick. Okay, I think I should be audible, right? Did anybody just write in the chat window if you can hear me? Okay, perfect. Right. I think I even have somewhere here a video of myself so that you don't have to do guesswork who's talking. All right. Perfect. Let's get started right away. And I have set up maybe something somewhat odd for a presentation. This is the page that I made for you guys in case that you wanted to go back and check also the commands and try to run what we do today. Today is going to be there's going to be a hands-on part that is not going to be as long as in the last couple of sessions. The reason is really because I need to do some explanation, but we do get to a point where you should be able to run your own Kubernetes cluster and try out what we've coded for people who are interested in cluster cloud orchestration. Okay, let's get started with what is Kubernetes. I probably don't have to explain so much, but there might be still people out there who are not familiar with Kubernetes so much. Well, first of all, it's a container orchestration system. You could really think of it as a kind of a cluster operation system. And the idea is that in a cluster, obviously, you have some sort of resources. This could be machines, this could be hard disks, this could be all sorts of stuff that you could imagine. And these resources have to be known to the system and have to be somehow managed. So this is part of the business. The other part is that now that you have all these resources, you don't want to be have people clash, fight over resources. So what you're probably going to do is you're going to be scheduling stuff that is blocking multiple accesses to the same resource with consequences for performance of all the services instead of just having one service running properly and vice versa. So the scheduling part is very important. And the third thing is that it, of course, needs to scale. Nobody knows when they start doing something in the cloud where the project's going to end. So you want to make sure that when you hit big numbers of machines, that you're still able to manage that and run that. Okay, what else? What is interesting about Kubernetes is there's a lot of energy being invested right now by, of course, Google primarily, but also the other big names in the business like Red Hat. And they are very much interested in investing time and energy because it really propels their business a lot. The whole thing starts pretty much at Google, and there was an internal fight about if people should really take what the experience that Google had made with container orchestration and put it open source or not. And the ones who wanted to do it open source, they won. Put Kubernetes on the network, and again, it's being developed by a lot of people out there. It's very, very exciting, and when you see at the end how easy it is to deploy an ArangoDB cluster, then I'm sure that a lot of you guys will reconsider the way they are deploying their clusters right now. I think the major idea is to help DevOps in this case because it is really not so easy to, well, maybe the deployment by itself is not so complicated, but if you want to take care of stuff like resilience and monitoring and vice versa, it really becomes very tedious and a lot of work that is diverting your attention from really important things like further developing your service and so on. Plus, it's done in a way that is standardized. It's done in a way that is understood very well because a lot of people use it. It just makes sense to deploy things this way. I'm going to blow up the font a little bit so that reading, yeah, because we have so much space, so I should have all this empty space to show for you. Okay, how is it done? Well, the way that everybody who's ever run a cluster, a compute cluster, or whatever, know that you have to somehow define what you want for a specific job. So say you need resource CPU, 32 of it, you might need resource memory, whatever, 16 gigabytes of it, and so on. So you define resource specifications. These resource specifications are communicated somehow to the API server. The API server is, in the backend, there's an etcd server that does some clever resilience consensus in the backend, very much comparable to the ArangoDB agency that we've touched upon a couple of times. It's doing the Raft protocol in the backend to achieve consensus. And anything that you discuss with this API server, if it's done in a way that it understands it, has consequences. The Kubernetes cluster then takes your resource, whatever it is, and tries to satisfy it. There are different resource types. There are the smallest deployable unit, which is a pod. There is services which consist of multiple pods and an access policy. There is a thing called, there are things called deployments, which are even higher level. These include now replicas and change management policy, like upgrades and vice versa. And then there is a place where actually all these things actually run. These are the nodes. And then we have all the authentication, access rights business, which is also included. Now, you could, of course, already do your Kubernetes deployment as Kubernetes is and as ArangoDB is. That is, that you would just write a 60-line YAML file that will explain all the resources that you need in all detail, and which this thing should somehow create the need for a pod. It needs somewhere to store the data. It's going to be a persistent volume and one service. And this will all sum up to something like 60 lines of YAML. It's not nice, but it's manageable, and it does the job. It's going to start for you with a single server. Might make sense. This is maybe your staging server. That's why it is fine if it's a single server. You're just doing your testing while you have your cluster running somewhere else. When you get to the cluster, however, if you take bare Kubernetes and try to deploy the ArangoDB database as a cluster on it, you now have to take care of a lot of things that are not so straightforward anymore. I mean, in the end of the day, you're creating these kind of YAML files now for 9 different pods. There are 3 agents. This is like the standard deployment of a cluster: 3 agents, 3 coordinators, and 3 database servers. And the coordinators don't have a persistent state, so you're fine with creating 6 persistent volumes. And then you also once more need the service. This is the service of the cluster. That's the only thing that Kubernetes is really interested in. The service is just combining all these parts somehow, and Kubernetes is giving you the infrastructure to have these services find each other. That is, it gives you DNS and vice versa. Anyway, this adds up now to some 450 lines of YAML, and it's starting to solidly head for a nightmare, really, because making mistakes here now is very, very easy. These YAML files don't, of course, have any sort of checking, because Kubernetes cannot possibly know what ArangoDB is and how it is configured. And if you make a mistake in the configuration of ArangoDB, then for sure that service is not going to start. And trying to debug all of that. I mean, it can be done, and we've done it before, and then realize really that it's not the fun way to deploy a cluster. That's why we invested the energy that I'm talking about today. Anyway, we have here the possibility, obviously, to take stateful sets. And stateful sets are great, make things life a lot easier. This would be very, very helpful to start the databases and the database servers and the agents and vice versa. So using those reduces some of those 450 lines and gives you a lot of the safety that you need to operate the cluster. But the problem is that it's still a distributed system. You still can make mistakes here in the definition of these stateful sets. And then the stateful sets don't help you really with doing taking care of upgrading requirements of ArangoDB, because once again, Kubernetes cannot possibly be expected to know details of ArangoDB and check if things are right or not. And if you want to do anyway upgrades, even if you did that properly, you would still be in a tough position if you wanted to have zero downtime, for example. What we do in a rolling upgrade is not going to be something that you can do with stateful sets. And again, tons of YAML still, and lots of possibilities to make mistakes. So let's see what you can do to get things easier. Again, it's obvious that we need simplification, and the important part is that you have a lot of different maintenance jobs that you have to take care of when you're operating a service, upgrades among them, these kind of things to streamline them. Okay, for example, consider the following. You might, by accident, want to go, again, just because you had a single typo in your YAMLs, go back from, say, version 3.3.14 to version 3.2.14. Probably not what you intended, probably something that can happen very easily. And if you had a service, if you had something that would be very watchful and know exactly the upgrade and downgrade paths, that's when you probably would be stopped going further. The system would tell you, okay, this is not a good idea, it's not going to work, I'm not going to do this. This is not something that you can do in YAMLs. This is something that you have to do in some sort of a mechanism, some sort of software that is taking care of that. So what about doing just a bunch of shell scripts that do the YAML generation? That would mean that once you've got the things set up properly and done right, you might still be on the safe side for at least generating the 450 lines or whatever you need to deploy a cluster, but you're still left out in the sun to dry when it comes to things like resizing your cluster and upgrading it. Again, also this could be conceivably done with the shell script, but now we are talking about the complexity that really doesn't make sense. I just, sorry, I just bumped the space bar. Where are we? Here we are. And so this really doesn't make sense. Okay, so what we do is we introduce the Kube-ArangoDB Operator. And it's really a set of operators, and it allows you to do something like this. The YAML file that you would need to deploy an ArangoDB cluster, a simple one with 3 coordinators, 3 DB servers, and 3 agents, would really boil down to these, what are these, 7 lines, 6 lines. It just creates a custom resource and applies it. This custom resource is give me an ArangoDB deployment. Very much different from having to create custom resources that are specific to a single DB server, specific to a single agent, and vice versa. How do you scale a cluster like this up? Well, the only thing that you need to do is you just take your YAML file here, this small one, and append it by these 2 lines, and redeploy this, reapply this. And immediately you will see when you watch your Kubernetes cluster, as long as it has still resources to suffice the needs of these additional DB servers, and you would get additional DB servers spawned, integrated into the cluster, and ready to use. And this is really, really very, very nice feature, that you have all these nice possibilities with just changing few lines, if many at all, to achieve what you wanted to do. In this case, expanding the cluster from maybe 3 DB servers to 7. You want to scale it down? Well, nothing easier than that. You just change the count down to 4, and your ArangoDB cluster will start to downsize again. Well, downsizing, as you can imagine, might maybe take some time, because some shards need to be removed from some servers so that they go concentrate on the 4 servers that are supposed to be left over. But it's, for example, conceivable that you have some service that has some rush hours. During those rush hours, you need to have more DB servers doing a job, or maybe you just change the number of DB servers for a specific task, for a backup, or whatever it is that you want to do, and then change it back down again. What about upgrading? Well, again, very, very simply, the only thing that you specify in here is just a specific image number, and then your cluster will automatically be upgraded in a rolling fashion and without service downtime. If you don't specify the image, then what is obviously used is the latest available version of ArangoDB. And from there on, you really have to specify the version numbers to change the image. This is an important place for explaining again the nice advantage of having an operator like this. If you would punch in here a wrong number, it would go back to whatever it was without changing anything. It would, for example, say you would punch in here 3.2.14 as accidentally. What would happen is it would go without effect, and you go check your Kubernetes cluster, you would see that the images that are still being run are the ones that were still properly functioning before you try to, in this case, downgrade in a maybe catastrophic way. Yes, that's supposed to give you an idea of the simplicity of how easy it is to cope with this, with these operators. And then, well, Kubernetes clusters are heavily protected from access from outside. They have internal networks. So all the services that you actually deploy to a Kubernetes cluster are among themselves reachable, but that would be the internal cluster IP. And there is no real way of accessing that IP network unless you actually attach some Docker container to that cluster with I can show you how it's done, to really just go deep in and do some local checks. It's very, very helpful, really, but it cannot be done in a straightforward fashion. But what Kubernetes has and offers for you is a concept called load balancers and the concept of node ports. The node port is just, as the name says, just a port, just a way to get some kind of a service, point of service out of the cluster. This would be, of course, a coordinator of some sort, and then be mapped to some port of one of the servers that has a public IP address. And the load balancers, of course, do exactly what the name says. They will take that that one port that goes out and then do load balancing on all the entities that you deployed within your cluster that would match the load balancer. In this case, in ArangoDB, it's going to be the coordinators always. And this way you could allow for a load balancing inside the Kubernetes cluster. It's really, really nice. It works without, it's seamless, it's without any headaches, it just works. In order to be able to do the load balancing thing, I'm sure that one of the last sessions we discussed that when you're connected to a coordinator with your operation, with your software, or even when there's somebody using the database manually using a client of some sort. There used to be a problem. We had to, if you had load balancers in front of ArangoDB coordinators, you had to make the sort of stickiness so that every communication that would come from a client to the coordinator to any of the coordinators would end up on the same coordinator. It has to do with the fact that, for example, if you have a result set sitting in a coordinator, it's only going to live there. There's no meaningful way of copying result set back and forth between the coordinators. That would create a lot of load on the network and on the coordinators, just crazy. That's why this stickiness was necessary. We recoded some of the coordinator code, and now load balancers don't need to have that feature. There's a coordinator ID that is now inside the results, and every time you use the same result set, or you're within the same scope of usage, you're going to be, even if you go to some other coordinate, redirected to the one that knows what you're talking about. So the load balancer in Kubernetes pretty much forced us to fix that issue, which is a nice thing. As a matter of fact, during the development of the Kubernetes operator, we did find a couple of bugs that were hidden, and nobody had found, not us and not the customers out there. It turned out that Kubernetes was actually a very good means to find a couple of nasty and not so obvious bugs in the software. Okay. This is the part that gets really tricky. The storage options on Kubernetes clusters are where matters get really, really tough. When you go to a provider like Google, the people who are putting a lot of energy in Kubernetes and have probably the easiest to use and most featureful installation of Kubernetes out there, then the best case scenario would be something like Google, where you have a lot of different options on how to attach sort of a hard disk, a persistent layer or so to your database server. It is obvious, I think I don't need to stress that too much, that locally attached SSDs are the best case in this in DB servers. I think it's obvious. The access times are very short, the latency is short, the amount of throughput that you can create on an SSD is really awesome. But there are also network volumes which can be used if your main focus is not the hyper performance. But these differences are visible. They're easily visible, and they bring the performance of a cluster down significantly. But let's imagine that you just bought 3 new machines that you put in your rack, and you would like to operate ArangoDB managed by Kubernetes. Well, it was clear that we had to somehow take care of that problem, and so there is a second operator that is part of the package. It's the local storage operator, something that doesn't come with Kubernetes. Getting this right wasn't really easy. This was easily 50% of the whole work that went into the development of the Kubernetes operator. Again, this is kind of a separate operator by itself. You wouldn't have to deploy this in cloud infrastructure if you're not on a dedicated blade or something. It wouldn't make sense. But you need something that, for example, provides to the database servers and to the agents a meaningful way of storing the persistent stuff. Because when you think of an upgrade, for example, that's when the services, that specific service, the specific database server, specific agent is shut down. Obviously, you can't lose the data just because these instances are turned off. So if you're on your own blades, be it in the cloud or in your machine room, this is something that you need to deploy along, or otherwise, if you start that code, try to deploy a cluster, you will see that the agents and the DB servers will be just sitting there, not getting the resources fulfilled, in this case, some local storage. The default local path will be valid Arango store, and we can later have a look into a Kubernetes installation with the ArangoDB cluster inside, and go and check out how these local storage volumes are handled. Just to give you already a heads up, this is really nothing more than just a directory in this case. So you're going to be on some file system that you have under valid Arango store. It can obviously be a link somewhere else to your, and you can, of course, change it in here. So if you have some super fast SSDs that you put on your system that are specifically meant to be used for the database server, not for the system, you just change this path to whatever is meaningful for you, and then deploy this. Okay, so just a feature summary, and I got a couple of nice things that are going to come for the next session, which is probably going to be in October, the 4th part that is concerned with data center to data center. Yeah, but let's get started up front. There are all the deployment modes that you can do with an ArangoDB, with ArangoDB instances, can be done with this operator. This is the single server. It still might be useful to deploy a single server somewhere in the cloud if you have already your Kubernetes cluster running. By the way, there is no reason why you couldn't deploy multiple clusters to the same, multiple ArangoDB clusters to the same Kubernetes cluster. Your Kubernetes cluster might consist of 20 machines, and you might have, I don't know, 5 or 6 different ArangoDB instances running. Some are for staging, some are maybe for backup, some are maybe for development. You want to maybe test active failover. You might want to do some tests with the DC-DC. So this is all possible while you're running your single Kubernetes cluster to do with ArangoDB clusters, or you know, active failover or single. Anyway, all the different deployment modes are possible. Okay, we were thinking that when you're using Kubernetes, you're probably going to be in an enterprise environment, that you're producing really something that needs to be safe, and it's something that is probably going to be used in a customer setup, exposed setup, whatever it is. And that's why we have decided that if you do standard deployments of ArangoDB in Kubernetes, unless you wish to not have it done this way, it's going to be automatically SSL communication between all the nodes and, of course, to the coordinator. What else? Your cluster is going to be automatically authenticated. Again, automatic doesn't mean that there's some fancy thing going on. It's just that your deployment will be automatically a deployment where you need a username or password to access your database server. Lots of you guys out there might think, what's the big deal? Well, nothing really. It's just that you should be aware that these deployments are not deployments that are going to be running without authentication by themselves. If you want to turn that off because you say, okay, I'm on the safe side, nobody's accessing this, everything is running within my demilitarized zone here. I'm safe, I don't need all this thing. The authentication is done within some session management in your application server or so, fine. But then you have to specifically decide to go down this route. Well, locally attached persistent storage with custom resources, I mentioned that already. And there is a very, very nice feature. You can set up data center to data center deployments of ArangoDB with Kubernetes clusters. There is a lot of smaller tools that provide you with all the goodies like taking care of all the TLS and secrets and tokens and whatever is necessary to get the two database, the two clusters connected. And there's very, very little specific knowledge of the synchronization between two ArangoDB clusters are necessary to get things going. And the next time when we're going to be together in October, as I said, we will actually do that both with and without Kubernetes deployments, and that should also give you some insight in the cool features of data center to data center installations. Okay, support for Kubernetes Federation is still pending. It's not there, in case anybody knows what this is and has some interest in it. If not, I really can't go in detail here. Just go online and read about it. It's fairly clear what the federation thing is all about. And then, yes, easy configuration. This has been actually where this whole thing got started. The easy configuration, easy management, easy change management, all of that is key features of the operators. Okay, so how do you do that? And there's two ways of doing it. The first way that we prefer really is using the package management, the Kubernetes package management Helm. The specific commands are at the bottom of this document. We get to them. Helm is awesome. Helm is, for anybody who's ever been using the usual way of using the YAML files and then praises the ease of using the Kubernetes operator, will even appreciate the Helm approach a little more, because now we are really just talking about a single command or something that takes care of all these kube-apply commands for you. It takes care of upgrades, it takes care of changes that you need to do to your cluster in a very easy fashion. It's just the next step of getting things done in an easy and streamlined way. It's just awesome. This is just published since last Friday, as far as I remember, or Thursday. I tweeted about it also, where we published version 0.3 of the operator that now does the entire Helm installation stuff. It's yeah, you will see that it's really easy. It's really, really nice. Another aspect of the operator is the vast amount of the possibilities of monitoring your system. This is, of course, including the log files that are inside the Docker containers. They can be accessed. It's, of course, monitoring of all sorts of stuff, be it the pod speeds, the services, be it the persistent volumes, the persistent volume claims, the custom resource definitions. Everything can be described and checked when you use the standard Kubernetes commands. So we've done we put a lot of work into getting as much ease for troubleshooting for admins as possible. Again, this is really a tool for DevOps. If you don't give them what they need to do their work, it's really, really hard sell for them. Well, and then there is a very nice and very straightforward continuous monitoring via Prometheus. This is the standard way of doing monitoring of cluster deployments today. It's like the hip way of doing it. Prometheus can be used for all sorts of stuff to monitor whatever disk usage, processor usage, RAM usage, whatever it is that you could imagine while you're running your bare metal cluster. But it is so configurable that you, of course, can monitor write accesses, read accesses, synchronous replication, communication between the DB servers, everything that you could imagine. The data center to data center communication that goes between two ArangoDB cluster, everything can be monitored using Prometheus. We actually use Prometheus in many cases to do lots of our debugging work. Without Prometheus, the development of this whole package would have been a lot tougher. Okay, so supported providers, and this is kind of a key point that I need to mention. First of all, the minimum requirement for the Kubernetes version is 1.10. This is, as far as I remember, largely attributed to the persistent volumes and the local storage business. And back then, when we were coding this stuff, this is a couple of months ago, it was like in February and January, it became also obvious how few people out there actually do Kubernetes for serious deployments. And this might sound odd to you, but for the big chips, for companies like Google, for Red Hat, and vice versa, it's never been a big deal to create storage area networks and provide those to virtualized hardware that does all this stuff, and then they needed Kubernetes as orchestration for that. But if you were a small database manufacturer, then you definitely didn't have the kind of resources at hand, and creating the kind of persistent volume provisioning that these big companies do is also not something that is necessarily in the future of a lot of startups. So getting things running on blades, getting things running on small deployments and so on, I think is very, very key. And again, this is the reason why we need Kubernetes version 1.10. Very often in cloud deployments, you can choose between versions. This is the version, this is the minimum requirement. But I need to also mention that there are different providers out there who offer Kubernetes bootstrap clusters. They are nowhere near equal. There is the big name in the business, GKE, Google Kubernetes Engine, that has pretty much covered everything, usually in an easy way to use. But everything that is regarding authentication, everything that might turn out to be somehow complicated on the provider that you chose, is going to be, in some cases, a new land for ourselves. So if you hit a problem, if you can't deploy your cluster on some provider, then we really need also that additional information, what provider we're talking about. We do heavy testing on GKE. We are testing some additional providers currently that are going to be production ready soon. So what else? There are the landscape of the special features that the providers give you is ginormous. So, you know, things like preemptive nodes, things that you might find on GKE and nowhere else, load balancer limitations, and then the whole business of IP addresses when it comes to public access to the service and so on. Again, every time we have a customer that might hit a problem with Kubernetes, we really need to have the information, what provider we're talking about, to actually go ahead and do testing ourselves on that specific platform if we haven't done already. Production ready since 0.3 is the operator is for the Google Kubernetes engines I just mentioned. And again, we are testing more platforms, but we aren't there yet. It's a lot of work. And federation support I just mentioned. Okay, let's actually get some things done. We have only 20 minutes left. Well, what does Kube-ArangoDB actually provide? It gives you the providers. It's all written in Go, and it's something that I should mention before we get our hands dirty. All the things, all the resources that we deploy into the cluster, we deploy as a pair. It turned out that the operators, of course, they get restarted if they crash or something like that by Kubernetes automatically. But it still can take some time until such an operator restarts. So we have usually a failover operator standing by, and there is a quick redirection done. One of the two operators becomes the one that actually does stuff, and then the hot standby would then jump in case the first one goes away very, very quickly. We use finalizers heavily, where these are effectively check marks. Do not clean this resource, do not throw away this resource to the Kubernetes cluster. These finalizers are avoiding garbage collection of, well, the garbage collection is a good thing, but tell the Kubernetes cluster that some stuff are not garbage and cannot be put away. These finalizers are very, very important for persistent volumes and vice versa. As long as the DB server is there that relies on some sort of a database underneath, data structure underneath, it's not going to be removed. And the way this works is you have the resources, some changes you might want to make to your cluster so that your whatever, change the number of DB servers, then a plan is created out of that change that you want, and then that plan is executed. There is a part that also monitors the entire system all the time and replaces things, takes action if necessary. Okay, let's get to actually deploy a cluster. I set up 3 machines here. These are 3, in this case, Linux boxes. I installed Kubernetes. Kube-ADM, for example, is, I think, a separate package on Ubuntu and on CentOS, Red Hat, and vice versa. It's very easy. There is a very nice page on the website of Kubernetes that discusses all these different Linux flavors. That's the only kind of deployments that I know of. So this is all going to be Linux-based. You do an initialization. This is, okay, again, this is directed at a deployment that is done on bare metal, okay? We have a lot of documentation on other deployments, but this one specifically addresses bare metal. And so you do a initialization. This part is necessary for what comes a little later. I will get to that. The next thing that you do is you copy the admin configuration that is created by this initialization in your local directory.kube. And once you do that, it's very nice. Let me just move over here. I'm just on my computer. There is a directory cube here somewhere. The configuration file here has all the necessary stuff so that you have access to your cluster as Kubernetes admin. This is pretty much the super user in Kubernetes clusters. And if I say kube CTL get pod, I should not see anything. Of course, there are pods running, but they are not necessarily in anything that is supposed to be touched by customers. As you can see, there's a lot of things going on in the backend, and yeah, this is the part of the kube system. This is also where the storage deployment goes, because storage deployments cannot go into specific namespaces. This is just a matter of fact with Kubernetes clusters. So just to show you this, and there are obviously other things that we discussed. We named services. These are the services. There's a kube system running. There's a DNS system running. There's, of course, the Kubernetes cluster itself running. And there is vice versa. But let's look at what else do we have here. For example, persistent volume claims. There is none of those just now because this is just a empty Kubernetes cluster. Okay, let's go back here. So this is why you do this, so that you can access your Kubernetes cluster, and then you deploy a network layer. Flannel is one that works out of the box. You might have different needs. There are different ways of creating these internal networks. This is just one of them. This is a simple one. And I think I did not even run this. I haven't even run this yet on the let me say sudo kube. Yep, I should know the password. And I think probably, yeah, that should be fine. Okay, what this does is it will also allow you to deploy stuff on the master node. Now, this is not something that is necessarily important. I just do it here because I don't have a specific need for a master to be outstanding in any way. If you don't do that, again, there is nothing that's going to be deployed on this one node. kubectl get nodes should also give us 3 nodes. They're all ready. This is the master node that I just logged in, kube01. As you can see, what else do we have? And on the other 2 boxes, once everything here went fine, I go ahead and I join. When this command is finished, you will see a join command that you can run on the other boxes. And this, I don't know, maybe on a normal system with good internet connection, this is probably going to run. If you do it for the first time, it needs to do a lot of Docker images, downloads, and it's going to be done within, I don't know, maybe a minute or so, and these go fairly quickly. This is a matter of a couple of seconds. Okay, so how do we deploy an ArangoDB cluster? Well, let's just go ahead and do it. Just take these couple of commands, and if you want to look what happened, we should go to CRD, and you see we just deployed this replication thing. This is the part that I mentioned earlier. This is the data center to data center business that I'm not going to touch upon this time. The database system itself, the cluster, what you would consider as the ArangoDB service, if you will, and then the storage business that is the third part of the resources that we deploy. The next thing that we do is we are going to deploy the current version of the deployment operator and go back and see what happened there. And we should see that there is now this ArangoDB deployment operator that is just started 6 seconds ago. If you go back, for example, to check with your pods, you see that there is this deployment operator, and there's 2 of them sitting there, as I mentioned earlier, for resilience. We also need to address storage. So we're going to deploy this guy too. This is because we are on bare metal. And this has consequences, again, for services. Sorry, yes, okay. As you can see, you see nothing. What's the reason? Well, as I mentioned earlier, everything regarding storage ends up in the Kube system. As you can see, this is sitting in parts of the cluster that are not necessarily visible to the outside world. And now the next thing that we need is, if you're going to do the data center to data center business, that's a replication operator. Now we can, let me go into my Git repository, Kube, ArangoDB examples. We have some examples that are in the repository. The repository you will find github.com, ArangoDB, Kube, ArangoDB here, but you will find all of these information in the material that you can access later. It's going to be also put on the YouTube page. Okay, this is, yeah. What we now need to do is we need to actually do a local storage deployment. So let me go back to the pods. And now let's deploy, apply. Let me see, which one did I take last time? Local storage. This has been created now, and also now I can just take a cluster, a simple cluster with no TLS, for example. Let's see what that thing looks like. This is just, you remember this part, this is not changed, but you might not have seen this line before. This is just saying that let's not use any TLS, just for ease of use in this case, and deploy that. Oops, apply, not deploy. And now we need to watch what goes on here. This is important. This one we kind of missed. You saw this thing here that terminated. What happened here is we quickly start up one instance of we start up one instance of that image just to check if things are in order, and also to acquire from it the ID of the Docker image. This is for us to be able to do all these things that I mentioned with the rolling upgrade and so on. After that, this whole cluster started. We have 3 agents here, 3 coordinators sitting here, 3 database servers, and we should be able to, let's go back and check for services. Oops, I don't need the watch. Just want to do this. And here we are. So this is our cluster. It started. It's got an internal IP address. It's here, but it can be reached also over the landline. This would be Kube-01 API version. Yeah, I need to log in. The default login is, oops, is root. And there we are. As you can see, this is a 3.14 cluster. We can actually go here and access this thing on port. What was it? I forgot. Find our ArangoDB deployment, log in, select system database, and then let's create a new one. Foo, and then change into that database foo, and create maybe a collection with I don't know, or with 9 charts and replication factor 2 or something. And this should also appear, and now you can see that we have a nice cluster running with version 3.14, and if you wanted to upgrade this, we would just go to the deployment file that I just applied, and let me see if this just works out of the box, or if I kill this cluster because I went too quickly or something. So let's take a simple Node.js, right, and tell it, I think this image is ArangoDB preview, as far as I remember, which is the current release candidate 1 for 3.4. Please don't use this in operation. And let's see what the pods are doing. Is there any magic happening? Okay, I'm slowly running out of time. I probably did some smaller mistake or something. I don't see anything going on. Usually it should immediately start doing, what is it? Simple cluster, no TLS. It does look good to me. All right. This classic fail. Sorry. All right. Anyway, I think I should have raised some interest in you guys out there to go ahead and play with this. And with that, I would just stop right. Yeah, maybe I should just mention where you find all this. I showed you where all of the information that I compiled here together is. These are the examples I was talking about. There is also some additional documentation. I did not show you the Helm part. The Helm part is this. So the entire deployment of a cluster boils down to these 2 commands in case that you need the storage. And you've got yours all set up. And when there's a new version, then you just deploy the new version, and it will just rolling upgrade your Helm installation. Is just the most awesome thing that is out there. Okay, with that, I'm just going to say thank you for listening. Let me just, before I forget about this, I'm just really bad at that. Let me just mention a couple of things. Please start us on GitHub if you haven't already. That's where you find ArangoDB on GitHub. This specific notes that I just showed you in the browser window, they are all found here. The course can be downloaded here, and also we are looking for people. We are hiring Kubernetes and Go experts. They are not to be found easily, but if you are one, please do have a look at the careers page, and that's where you can do the slide download. Thank you very much. If you have